Okay, we're looking at geometric mean theorem, specifically talking about the leg. Now this is different than yesterday's altitude. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this triangle is the geometric mean. Between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So we have another ratio. You'll recall that we said we'll call this length, actually let's call it D. Yesterday we looked and we saw that the altitude D was the geometric mean of X and Y. Excuse me. Today what we're seeing is that the geometric mean is that we can use the leg as the geometric mean. So B is going to be the geometric mean between the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. The hypotenuse is this length, C, and the segment adjacent is this length, X. So that's what we're going to get from this. And likewise, we can do that with the other side. This leg, use a different color. This leg, A, is the geometric mean between the hypotenuse and the leg adjacent to it. Okay? So let's use that example or that theorem to solve here. It says to find X, Y, and Z. Now we can use either theorem, the one from yesterday, the altitude, or the leg, using the altitude or the leg. So in this case, let's do what we did from yesterday. Notice my altitude is X. So I'm going to say that X is the geometric mean between the product of 5, this segment, times this segment, the square root, 20. So X equals square root of 100, which is 10, isn't it? So here we have X. Okay, the next thing we're going to look at, let's erase that. And it's not letting me erase it. That's okay. I don't know why it does that sometimes. Now we're going to look at the leg Z. Remember, Z is the geometric mean between the hypotenuse, the whole length, which in this case is 25, times the leg or the segment adjacent to it. So 25 times 20. What we get there is 500. And the square root of 500 is we get a decimal, so let's go ahead and use the cake method to simplify that. 500 we know is 5 times 100. Well, 100 is a perfect square. That's 10 times 10. So I have a pair of 10s that I can pull out. And the 5 stays inside. So Z equals 10 radical 5. Alright, let's look for the next one. The last one is Y. This segment here. Notice it's a leg of the large triangle. So it's going to be the geometric mean between the hypotenuse, which is 25, times the 5. So y equals square root of 125. And if we use the cake method to solve for that, we know that that is 5 times 25, which is 5 times 5. I have a pair of 5s I can pull out. So y equals 5. That other 5 by itself stays inside the radical. That's not x, that's a y. Alright, let's look at the assignment. Okay, you've got problems just like it. We're looking for the missing length. Number 1, we just did a problem like that. Let's look at number 2. This one, we're looking for x. Now we know what 10 is, and remember, 10 is the leg, so it's the geometric mean. So 10 is equal to the hypotenuse, 24, times the segment adjacent to it. In this case, that's x. So if we square both sides, we can get rid of the radical, leaving us with 100 equals 24x. Divide by 24, and go ahead and simplify that. We end up with 100 divided by 24, 4.16. We could round that to 4.2. Okay. Number 3, similar to the one example we did. 4, we just did an example like that. 5, we did. 6, no different than number 2 that we just did. The only difference is we're going to have the x as the whole length, and 3, so we'll have 3x. Let me write that for you. We would have 8, the leg, the geometric mean, between the hypotenuse and the leg adjacent to it, which is 3. Square both sides and solve for x. Number 8, it doesn't have an x, but it says find QS. Well, QS is the whole hypotenuse. So we're going to say this segment, the leg, 40, is the geometric mean between the segment adjacent to it, 32, times QS, the hypotenuse, which we can just call x. Okay, and on the back page, again, they're all very similar to each other. Geometric mean, you remember on number 16, all we're doing there is we're saying the geometric mean, x, is equal to the square root of 10 times 9. And simplify that. The word problem, a surveyor sketches the diagram to the right to calculate the distance across a ravine. The distance he's looking at to get across is this NP right here. What is x? The distance across a ravine to the nearest tenth of a meter. So you have a leg, which is 8.3. That's going to be the geometric mean. It's equal to the square root of the segment next to it, 4.2, times the hypotenuse. Well, the hypotenuse in this case is x plus 2 plus 4, or x plus 4.2. So we're going to have to distribute that 4.2 over, so we're going to end up with 4.2x plus 4.2 times 4.2 is 17.64. To get rid of the radical, we square both sides. That leaves us with 8.3 squared is 68.89, and that's going to be equal to everything under the radical And there, that leaves us with this. Subtract 17.64 from both sides, divide by 4.2, and you'll find your x. Again, nearest tenth of a meter. Okay, that's it.